Hello, everyone, and welcome to this water climate discussion to explore how the radical change idea of reversing water cycles could support improved climate mitigation, resilience, and improved biodiversity. This event is hosted by the Foundation for Water Research, or FWR, an independent community of professionals from across the water sector and related scientific specialisms. The community comes together for deliberative discussion to support the development of interdisciplinary solutions to water challenges. I will pop a link to the website for more information in the chat a little bit later on, along with a link to sign up to the free FWR newsletter. This event is set up as a meeting to support greater discussion and interaction. But whilst others are talking, please do keep yourself muted just to kind of limit background noise. The event is going to be chaired today by Dr. Martin Currie. Martin is an independent potable water quality and treatment specialist with Aquium. He has been hosting the water climate discussion since the run-up to Glasgow's COP26, when the water sector got together to bring their voice to the climate discussion. Martin, I'll hand over to you. Thank you.
Thank you very much, Ethne. And yes, hello and welcome to the Water Climate Discussion. So this year we're discussing radical change, and today the radical change that we want to discuss is reverse water cycles. We are recording this roundtable, so please keep your cameras off and your mics muted until you're asked to speak. And if you don't want to be included in the recording, please keep them off, and you can add a README to the start of any comments or questions that you post so that we know just to read them out. Otherwise, we'll ask you to unmute and give us them in person. So as Ethne mentioned, today's roundtable is brought to you by IES's Foundation for Water Research. But there is even more to the water climate discussion. We started this year with a launch video on LinkedIn asking people to think and post their ideas for radical change. Joe Burgess brought the first radical change proposal back in June with a post on marine cloud brightening. I think it's safe to say that Joe considers it a dangerous idea, but it might be something that we're forced to consider. Piers Clark posted his suggestion on composting toilets a couple of days later, and it has generated a lot of discussion. If we were starting from scratch, I'd like to think that we'd go with composting toilets, but the mere suggestion caused heated debate, which is exactly what we're looking for here. My proposal, that we take longer baths and dream up climate change solutions, was rather more frivolous. Amanda Lake's proposal on food is actually much more aligned with the radical change that I'm personally working on with the Amy Bow community. Most recently, Steve Kennedy gave a very practical but equally radical suggestion on household water management measures. IWA then hosted the first roundtable back on the 3rd of October. Then RSK had a webinar on sponge cities. And you can access all of these, if you like, later via the Water Climate Discussion website. So you can sign up for next Thursday's main event. And there's also detailed instructions on how to propose your own suggestion for radical change down here. Anyway, I have waffled on enough, so let's get on with today's agenda. We are here with the intro, and we're going to run our first poll next. Then we have two speakers. So they'll only be presenting for 5 minutes each. So they're more here to get your creative juices flowing and start the ideation process than to present any finished answers. First, we have Anna from Imperial College. Anna's going to talk through the brand new radical idea of implementing a water cycle climate controller. And then Simon from Atkins is going to be talking about reversing the human water cycle. Again, just forcing it's a round table, and sorry, I should have asked Ethne not to give me a big thing. I don't have big bombastic intros for our illustrious speakers, but you can read all about them at the foot of this QR code link on the Water Climate Discussion page. So we'll then launch into our second poll, in which we decide which of their main points we want to kick off the actual discussion with. And then we'll really get into it with the actual discussion. So please post your thoughts, questions, suggestions in the chat as soon as they come to you. Again, this isn't a session in which we're expecting to get all the answers from Anna and Simon. We want to ideate and get answers together as a proper discussion. So please do stick with the topic of reverse water cycles for now. So anything you can think of that is reversing water cycles, I guess. You'll learn a lot more about this, particularly when Simon's explaining the main idea. But if there are other topics that you want, other proposals for radical change, just hold them for now, and I'll explain how you can propose those at the end. So as I mentioned earlier, we are recording this roundtable, so please keep your cameras off and your mics muted until you're asked to speak. If you don't want to be included in the recording, just keep them off and add the words "read me" to the start of any comments or questions that you post so that we know to read them out ourselves rather than asking you to share your camera and ask in person. And if they relate to particularly to the stuff that Anna's going to be talking about, then you might want to put an @Anna at the start. If they relate to what Simon's talking about, @Simon, and we'll basically have them picking out comments, questions, suggestions in turn for us to discuss. So then with that, if you want to say something just quickly in response to what we're currently talking about, rather than changing the topic to something else, please do the hands up thing. So I think that's basically the react. I'm looking at the bottom now, I'm seeing react. I hope this is the same for everyone. And then just above react, when you press the react love heart, you get raise hand. So I think that's how you raise your hand. But yeah, please keep those responses fairly quick and concise so that we can cover all of the suggestions that people put in through the chat. That would be brilliant. So finally, if there's time, I'll try to do a little wrap up and our final poll before explaining the next steps, what we want to do together or individually, and other suggestions for radical change beyond the reverse water cycles. We should be done in around 80-something minutes from now. So yeah, Ethne, can you launch the first poll for us? And there it is. So poll 1, water climate. On climate issues, do you think the water sector is going too fast? Or do you think it's leading the world? Do you think it's going as fast as funding permits? Or is it going too slow? I'm trying to work out, I don't think I can vote myself. I think you might be able to vote for more than one thing, although I can't actually check that myself. We'll keep going a little longer, I think. Okay, and your final chance to vote. Do let us know in the chat if you're unable to vote or anything like that. I'm gonna close it in 3, 2, 1. Well, I'm not gonna close it, Ethne is actually. And the results are basically majority seem to think we're going too slow. Then there are not that many fewer who are saying that we're going as fast as funding permits. So it seems that funding is the blocker. And we have one person who thinks we're going too fast, which is a very valid viewpoint too. Okay, so next up we can lose that poll, and I'd love to just hand over to Anna. Anna, are you able to share your slides now?
Yes, thank you, Martin, and thanks for everyone for joining. My name is Anna Mijic. I'm a professor at Imperial College London of Water Systems Integration, and I'm also involved with the Institution for Environmental Sciences with their policy committee and also foundation for water research. So in the next few minutes, I'll talk about the idea of water cycle climate control. And I have to say, so when Martin briefed us, he said it has to be radical. So this is radical, and it's very new thing that we are thinking about. So I'm really looking forward to the discussion. So I'm just going to set the scene. I guess the first thing, if we're talking about the water cycle, we should define this. And I put this small illustration because it will help me explain the idea. So this is something that all of you recognize very easily. The hydrological cycle of the propagation of water through the system. And of course, from the perspective of the movement of the water and how we normally model the systems, we see the precipitation as input and then creating the flows, which again, in extreme cases, and this is what we are worried with the climate change, lead to floods and droughts. Of course, then we have other human activities, and this is really important in this context because it is not only the issue of flow. We know that we have issues with water quality, and we know that flow and water quality interact. So this increases the complexity of the human water cycle. And of course, at the end, we have the feedback. So we have something that normally in our models, we look at the output, which is the evaporative fluxes, which go back into the atmosphere. But then this whole idea is a result of basically us working a lot with climate scientists and looking at the work they do around the climate change. So lots of our work is looking at what the future climate is, how we manage systems in the future. So from the perspective of the climate systems, which are normally inputs to our models, this interaction between the land and climate is very important. And there is this whole regional climate system which interacts very closely with, with the hydrological and water cycle system. So if we see this as one system which physically is coupled, then the question around the inputs and outputs becomes very questionable. So then what we did, we looked at the literature to see what is the evidence on water cycle climate feedback, and there is a lot of evidence. So climate science is really interested in those feedbacks, and the analysis of those feedbacks comes primarily from the climate sciences and regional climate models. And I have chosen just a few examples, and if you're interested, I can send the detailed references which give evidence around the coupling in different parts of the world. This is the paper from 2015, doing the analysis for the Mediterranean region, showing that precipitation recycling, so evaporation that stays within the region and comes back as a precipitation, increases soil moisture and reduces surface runoff. We see similar analysis for China and the increase in the recharge compared to the uncoupled simulations. So when we see the climate input only as a boundary condition, there is a really interesting paper in India that shows that even in situations of water transfer, and the rainfall induced from the water transfers or enabled by water transfers can reduce the mean rainfall in the monsoon season, which is really critical for example, India water resources. And we see similar patterns in the studies done in East Africa. So if we try to summarize what are these changes at a very high level, we can say, well, if we look at the human water cycle from this couple perspective, we see a couple of things that should really worry us. So we see the reduction in precipitation, we see the increase in soil moisture and increase in recharge, we see the reduction in surface runoff, which then potentially can lead to intensified risks. So all our work is on water management. So what we are interested is to say, well, what are the implications? Do I have to deal with more groundwater flooding? Do I have to deal with less water in the rivers? Or do I have to deal with much more polluted rivers? But then all of this can kind of get us to think, could this be an opportunity for a radical change? And of course, where the link comes is around the land use decisions. So when we think about the hydrological cycle and water cycle, we normally think about the natural part. The human part is, of course, the huge element. So if our land decisions are defining the land-climate interactions, and then consequently also the need for water and the resources, which Simon will cover in much more detail, then I guess the proposition here is, could we transform our development to design a human water cycle that controls regional climate and reduces the frequency and intensity of climate extremes? And this is what we at this stage call water cycle climate controller. So just to finish, I'll just give a quick example, which just opens the discussion around how we might do it. So I think one thing we might think about is altering the evaporative fluxes to manage recycled precipitation, considering the land infiltration capacity, how that would look like, what that would mean along which spatial scale, how long it takes for these systems to get the feedback we want to have. And then, of course, if that is possible, then what we do with the increased source of water, how we then use it either directly into the supply or we leave it in the rivers to help with dilution capacity. Of course, this is, for me at least, opening many other questions, and this is something I would like us to discuss. Is the evidence we have sufficient? Do we have more evidence? What other scenarios can this go terribly wrong? There are, of course, examples of intensifying the climate feedback and going into extremes and tipping points. What is the most significant challenge in developing those solutions? And if it all works, then what next? So this is all from me. Thank you very much.
Brilliant. Thanks, Anna. Next up, we have Simon. Simon, can you share your slides?
Okay, great. So yes, I'm wanting to introduce this concept, reversing the water cycle, along with ideas about how we can have a truly sustainable water system. Just to introduce myself, Simon Spooner. I'm Associate Director at Atkins Realis and also the Atkins Realis Fellow for Water Quality and Carbon. I'm currently the chair of the UK Foundation for Water Research, and I have a 30-year career which has been variously between the UK and China, which has given me some sort of different perspectives on how things might be done. So to introduce this idea of reversing the water cycle, the basic principle is to think about how we have evolved in our use of water. And we think of maybe, back in long ago, a family traveling around would stop by a river, get their water from upstream, dump their waste basically as near downstream as they could get away with, and be more or less in tune with that river and drinking that living river water. As industry has evolved and we have industrialized, so we build cities and we start reaching ever further upstream to reach our fresh water, and we have to dump our waste further and further downstream, and then we have to treat it before we dump it. But we're still just doing the minimum we can get away with. The problem is, as we reach further upstream into the mountains or down into the ground, we're kind of sucking the life out of the river. We're destroying the natural flow. And effectively, we've stolen the water from that living river. And the river is no longer, has the kind of healthy aquatic ecosystem that we would be hoping for. Together with what we do in the river, we also dramatically change the land. We clear and we burn away forests and grasslands. We plough the land, industrial scale agriculture, and this is destroying the soils, their health, and very much their capacity to store and purify and manage water. And this goes into our own bodies as well. So in the old days, drinking from that living river, our bodies, our biome, our ecosystem within us was in harmony with that living system. And we have an immune system that is designed to work in that way, and that is managed. Now, and if we don't have exposure to all of that diverse microbes and different things, this is leading to an epidemic now of immune disorders and health conditions. Now, there are a lot of complexities and controversies around this. And there is also the fact that although the exposure to the natural world may make you healthy, it's a bit on the case of what doesn't kill you makes you stronger. So there are significant issues with also being fully in touch with the natural world, which is not always a good thing for us. But basically, that whole biosphere system around us is no longer as healthy as it used to be. So this water cycle, as it should be, is a complex system, and we've been driving it in one direction, sort of pushing the water from the top to the bottom and impoverishing in between. Now, I want to slightly divert a bit, because to understand how we can change this, we have to understand where we're going with climate change, with our energy transition, in order to come up with the solution to this. And so for this, I want to make the point that our current climate and atmosphere are a result of living processes that have happened over hundreds of millions of years. That process of extracting carbon into the ground, laying down the fossil fuels, and also limestone, taking the carbon dioxide out of the atmosphere by living things, that creates our climate system. It also is very important in our water system, and it's living things which create the soils and this whole balanced system. When we burn fossil fuels, we are consuming that biosphere of the past, this whole biological system that creates our climate and situation. We are basically consuming that, and that has made humans wealthy and numerous. It's a very, very powerful thing that we can do, but very destructive. Where we have to go is to stop burning everything. It's easy to say, very hard to do. I describe this more in a concept called combustion transition, this process where we have to move away from burning living fossil fuel to harvesting our energy in a more sustainable way. And this can involve what I call bypassing the biosphere for energy. It sounds like a very strange phrase, but it is possible now. Instead of consuming living and past life, we can generate our energy more directly. And this is the concept. Almost all of our energy ultimately comes from the sun and nuclear processes, which we can harvest either through the biosphere, through how it's been locked into that system, which is what more than 90% of our energy is now, or we can go through renewable routes, taking basically the direct solar energy, slightly more indirect from wind, bit of gravitational energy with tides, and heat energy, which is ultimately nuclear decay from the ground, or we can take our nuclear energy directly from the isotopes that we can find. This is a way of getting all of those energy services we want, bypassing the biosphere, not going through the biosphere. And within this sort of biosphere idea, there's another end member of how we can get the services which we need, which is to embrace the biosphere. If we, especially for food, if we work with the systems, we make ourselves part of that living system, then we can also get services. And what we tend to do is something in the middle, which I call enhancing the biosphere. So that's where we add structure, we add energy to a living system, we work with it, and we get more of what we want, but maybe give less to other things. So when you plow and you structure a field, that and you add fertilizer, that's enhancing a system, and that has benefits for us, but not all of it's good. So where do we want to go? With that sort of bypassed energy system, we can actually in the future conceive that we'd have much more abundant renewable energy, and we can use this to reverse the water cycle as well, in a way bypassing the biosphere for water as a parallel to what we need to do for energy. Also, in the catchment, to be more embracing of the biosphere system, working with diverse agricultural systems, the regenerative type of agriculture. I was a little careful with the term regenerative. It can mean many different things, but ultimately it's the idea that instead of just taking, we harvest what we need, but we also give back to the wider system. This will then restore the hydrological functions within the soil, and allow us to sort of work more as a part of nature. So what does this look like? Just trying to visualize this in quite a sort of rough way. This is sort of what we do now. We take the water from above us, make a right mess of it, send it down to the sea and consume it. What would reversing the water cycle be? This is basically taking that water from downstream. So we leave, the essential thing is leaving the water in the river to create a living system. We then take it once nature doesn't need it, then we start to take it, and then we supply ourselves through an independent system. That means lots of treatment, lots of pumping. It takes energy, it takes infrastructure, it takes organization. It's not the way that we've been doing things so far. But I want to point out, there is actually, for humans, there is no such thing as a water shortage. There is just a shortage of energy, infrastructure, and organization. So we can make as much water as we need. But we need to learn how to nurture aquatic ecosystems, how to create this system that will put the life back into the river. And in some ways, that means that we need to sterilize what we put in to a far greater degree than we do at the moment, and let the river put the life back into the water. What comes out of a wastewater treatment works at the moment, has a lot of very, very distorted biological assemblages in it, and it's part of why our rivers are not healthy. So we need to change that, and this will need these abundant supplies of energy to do it. There will be many benefits of this to increase the total amount of water, a lot of the resilience, and also having the sort of interaction with climate that Anna was talking about just now. And this sort of matches with the whole circular water economy, recovery of heat and materials, and how we can make the system healthy. And just to finish now, and to move, as we move into the questions, the big question, I've said some nice stuff, but so what? How do we actually do that? And what I have developed is a proposal for the approach to actually doing that, which I call stakeholder-led infrastructure transition. And this is a sort of a layered way in which we can go about that. I'm not going to describe that now. We're going to move into the poll. If you're interested, it's a bit of a pitch here. We can talk about that. I've got a few more things which can explain it. But this is the discussion. We may go in other directions. So I will pass back to Martin now for the poll. And should I stop sharing my screen at that point?
Yeah. Thank you, Simon. That's correct.
Found it.
Yeah, Ethne, can we have the poll? We're running a little over time now, so we'll try and do this. If you can vote really quickly, please. So here we have the poll. So which proposal basically should we discuss first? So the first one, do we have sufficient evidence to support the claim about the strength of interactions between the water cycle and the atmosphere? What other water cycle scenarios or alternative mechanisms might trigger the feedback between the water cycle and the atmosphere? What's the most significant challenge in developing and testing water cycle atmosphere interactions? If we could develop climate positive water cycle solutions, what steps would be necessary to move them towards implementation? And will taking from downstream and supplying people directly really improve our rivers? Will we be healthier with our own biome linked with the biosphere around us? Can we build systems that will fund and support individuals or communities to change their buildings and land use? Or will the transition of our energy system to electrical systems supplied by renewables allow a circular economy of water and materials? Okay. I realize it is quite a long list of fairly long things for you to read, but yeah, we've got 55% participated so far. And we don't have a clear winner yet, so I'm gonna just keep it open a little bit longer until we've currently got a two-way tie. Three-quarters of us have voted. I'm not seeing a lot of movement, so there we go. We've got a winner. Okay, let's end the poll now before we go back to a tie. And sharing the results, I pretty much believe that the winner of our poll is will taking from downstream and supplying people directly really improve our rivers? So that's one of Simon's points. So the main thing is that we just discussed this. So please put your hands up and share your thoughts on that. Does anyone think that it won't improve our rivers, or do you think it will? So if you can click on the react button, that's the love heart at the bottom, and then once you've done that, you should get raise hand at the bottom. So I wonder, is anyone's hand up yet? Am I not seeing hands up because the poll's still showing?
I don't think there's any up yet.
There's no hands up yet. Okay, so we'll take that. That's clearly one of Simon's issues. So will supplying from downstream, taking from downstream and supplying people directly really improve our rivers? Simon, why? I mean, to me, it seems like it should. I can think of one example, maybe where it doesn't. But yeah, are there many scenarios in which you envisage in which taking from downstream and supplying directly wouldn't improve our rivers?
Because I think the question there is always how far downstream. So the easiest to envisage scenario is that you take from just before the river reaches the sea. So basically you've got the full flow of the river there. It's still fresh water, and then you treat that to a high standard and you pump it back to supply your towns and cities. And an example of that being planned would be the Fenland reservoirs in Anglian region. So here where I am in Cambridge, we are a water short area, and that's limiting our development. And there are no nice big mountains to reach up into and reservoirs to pull from. There are just our beautiful and unique chalk stream environments, which we are sucking dry from underground and destroying. And what we want to be able to do is to stop taking from those aquifers that create our rivers, allow that water to flow by letting the water go by, and then taking it, putting it into the reservoir, treating it, and supplying to Cambridge and other towns and cities in the region. So that would be an example, and maybe one of the only ways that we could really allow the rivers here to improve. The other extreme example of this, of course, is desalination. If you take from the sea, then you're not impacting the rivers at all with your abstractions, but you are still discharging the wastewater into the river, which will have the impacts on that. And that's why I think, as we are planning, as we are working to ever improve the quality of the treatment, so that what we are putting back into the rivers is actually a more sterile, a more pure water, that the natural ecosystem of the river can then revive and turn back into more of a living system, so that what comes out of our treatment works isn't distorting the aquatic ecosystem with masses of sort of leftover microbes from our activated sludge plants and things like that. So these are ways in which we can improve. Where it may not work is, when you've got a long stretch of river and you're just sort of shuffling things around, sort of part of the way down and part of the way back up again. It could get quite complex there. And ultimately, this would be about having a balanced system where some is going in reverse, some is coming straight down, and it will just be a different way of looking at things. So I think that's probably a long enough answer on that one.
Yeah. We've had an interesting comment. It's a README, so actually for now I'm not even going to mention who said it, just in case they don't want to be recorded with their name either. But the question is, would taking our water from downstream to supply our water be a big enough step to improve the quality if we don't address the issue of agricultural runoff upstream, particularly from large poultry units? And I think this is a massive issue. Potentially, things could get even worse. I mean, the example that I was thinking of, I was working at a very large, very famous utility who were building or were proposing. I was working on the design team for a very large and very controversial reservoir at the time, and the EA were requiring the water that we returned to the river to be returned at a higher quality than it was abstracted. And some of our modeling was actually showing that this was going to have adverse impacts on the river water quality. I'm thinking similarly, there are scenarios in which we're introducing water that is actually, if you're in an area where you've got a lot of this poultry runoff, I think the wastewater treatment works discharge could be beneficial. But Anna's got her hand up. Anna, do you want to address this?
Maybe Simon comments first, and then I'll follow up.
Cool.
Okay. I mean, I think this really comes down to how we have to shift our whole agricultural system towards this model of embracing the biosphere, working with the living system, and seeing ourselves as a positive part of that system. So, when it comes to the sort of poultry farming, ultimately, the factory entirely indoors poultry farming is not ever going to be a really healthy way of feeding ourselves. And we do need to work out how to spread that out a bit more, be a little bit more extensive with it on the one hand. But there is another way of looking at where we have to take the farming systems. So I might be contradicting myself here, but I would say that we need to go down the two routes, one of embracing and creating more of a living system, and the other of bypassing in our food production as well. And in bypassing, that's again where we go for the ultra extreme industrialized farming, the sort of entirely indoor farming system where we are separated entirely from the natural world, controlling everything and getting incredibly high levels of productivity in certain crops, certain products, and also synthesizing proteins, synthesizing starches and sugars, rather than necessarily growing these in natural systems, so that we are getting some of what we need without impacting on the living system. And then where we do work outside with the living system, then making that more diverse and valuing the sort of multiple benefits of improved water services, flood protection, climate services, as well as just the food product that the farmer may be producing. So I think it's part of this entire new way of tackling our food and land use system. So Anna.
Yeah.
maybe just on these questions, and I think it covers maybe even the question afterwards. I think what is really important to think about here is dilution capacity of rivers. So if you leave more water in the river, you will increase dilution capacity. So theoretically, Simon's suggestion, leaving water should help with pollution. So you can imagine if you have more water, the same load, your impact will be less. So theoretically, of course, that's kind of from the water balance perspective, that should really help actually, I think, with the water quality. I think the second thing which we may need to think about is the other extreme. So what happens with the high flows if you leave more water in the river? So I think the leaving the water in the river will always be beneficial for resources and environment and water quality. There may be situations where the increase of flood might happen, and I think this is something that needs to be managed.
Yeah. With that, just also one little point on Simon's last point there. Yeah, on the food thing. Next week, one of the breakout groups, I don't want to tempt you away from the one on reverse water cycles too much, but my breakup group will be discussing food. And yeah, absolutely, things like hydrogen oxidizing bacteria, we can produce them to produce whole biomass, so we eat the whole cell, so there's no waste product, and we can just recycle everything internally with no wastewater discharges whatsoever. But yeah, Anna, I'm wondering, are there any points in the chat about your proposal that you'd like to discuss now?
Yeah, I think there are lots of questions coming around I guess, the practicality of the reversing water cycle. So I don't know if we want to maybe, discuss maybe a few of those and then let people maybe put in a few questions around the first idea, and let's see how it goes.
Sure. Okay. So I've just thought of, because we can't use a Q&A in this system, I'm adding a little party to da sign thing to the questions that I believe we have answered. Anna, which one would you like to cover next then?
I think this is interesting one around the acceptance, isn't it? And I think one of the things that came out at the beginning was, yes, we are progressing according to the funding. So there's a question around, would our parliamentaries ever countenance the necessary change in legislation policy and compelling water authorities to re-engineer our water and wastewater infrastructure and to reverse the current water abstraction model, which I guess in a way covers both topics, because I think both things that we are kind of discussing today do require a lot of, I guess, evidence on one side. So we really need to think about how that all might work and what kind of changes in the systems are needed. But then eventually it would either require a lot of funding, which is on one side. It would require a lot of acceptance from people to kind of, drink different water and drink basically reuse water, because all the water coming at the estuary will be the one that's already been discharged from or most of the water will be discharged from somewhere. And it also, at least in the what I was discussing, would require significant changes in the land use planning and development policies and the regional planning, likely to constrain the development. And I think this is something that, from the implementation perspective, could be a significant challenge. What I would probably think as the best, or the kind of one of the ways forward, would be creating evidence, more and more and more evidence, even if that's maybe just on the kind of modeling side and theoretical side, how things might work. And then I think we really need to think about the benefits or co-benefits, everything that we can find positive in the solutions, and how much it would reduce extremes, make the operational water management easier, possibly, you know, mitigate, offset some of the climate change impacts, which in longer term will provide benefits. Initial investment, I think, will always be the case, and the challenge. I'm still not convinced that not just UK government, I don't think any government is ready to really seriously take climate change into consideration and invest what needs to be, I think, huge investment. We've seen what happened in Spain yesterday. It's really devastating that in 21st century we allow such devastating impact of flash floods. So I'm not super optimistic, but in a sense, I think we just need to keep trying to work with authorities and convince them that this is something we really, really desperately need.
Yeah, brilliant. Now, we've had our first non-README question, so I think I'd like to jump to that one, just to show that we really do want people to get in here, turn their cameras on, and ask their questions. So yeah, Michael Smith, if you're able to turn your camera on and unmute and make your point here on agricultural runoff.
Hi, sorry, I've dropped myself in it a bit here, haven't I? Yeah, so I currently work as like a flood risk and drainage engineer for Allen Wood and Partners. So in industry, a big part of my job is to, I guess, deal with agricultural runoff, especially from poultry sheds. I mean, it's a big part of the business in all fairness. But we obviously meet all criteria, like using the Syria C753 criteria manual as guidelines. Implementing SUDs in, as there could be anything from swales to filter drains, filter trenches, attenuation basins, all them things before it goes into discharge into any watercourse or soakaways, all the usual stuff. Obviously, if that's not up to spec, how do we then mitigate against that? If obviously the point earlier was mentioned about it potentially not being enough, is like at this point is a farmer can only mitigate against what he understands really, and he'll only ever follow the law. So like if we're following like, I guess all the legislation like the MPPF legislation, following building regs and things like that, is we're essentially as planners and engineers, we're only doing everything that we can and in our power really to implement these rules. So like, how would we go about, I guess, improving water quality when from our understanding it would already be probably better improved in all fairness once it's gone through various filtration systems?
Yeah, I mean, I think that's a brilliant question. I'm wondering whether the main issues that we're having are actually people who are not following the regs, because I understand there are a fair few of those. Reading the press, it suggests that prosecution is very rare for those who don't, but others have more of a expert. Jacob's hands up. Yeah, let's hear from you, Jacob.
Yes, hello there. I heard over from like some sources and like from some teaching lessons that agricultural runoff is also one of the main causes of damage to water quality, like for example algae blooms, since due to like all of the fertilizers and nutrients contained in like agricultural products. That can be also more dangerous if it's in areas like monsoon areas like India. So I was just kind of wondering, do you know any areas that might be mostly impacted as a result of damaged water quality due to agricultural runoff?
Yeah, should I address this?
Please.
I mean, I think when it comes to the legislation and the requirements, say, on agricultural runoff, poultry, things like that, at the moment, we don't have a fully joined up system. So although you've got regulations, I don't know the details of the Syria C753, but a lot of that impact is to do with nutrients, the phosphorus and and to a lesser extent the nitrogen. And our actual targets now, the latest targets we've set for our rivers, are incredibly ambitious to achieve based on current technology and current emissions regulations. So a lot of the requirements which are set to the water companies and to agriculture and industrial discharges, what they're required to do is actually insufficient to achieve what we're aiming to achieve in terms of a healthy river system. It is there is a long way to go. And this whole reversing the flow thing, this is a long-term project. It's not going to happen, you know, within the next AMP period. Ultimately, it will take the same sort of time that it's taken for us to put in our current water infrastructure. So turning that around to operate in the other direction, it will take 100 years. But we can start now, and we can think about how we can progress in that direction, because the end goal is an actual sustainable water system where we have as much water as we need, pretty much. We won't be able to irrigate every field, but we can certainly look after ourselves, and we can have healthier and living rivers. And
Anna,
yeah,
I
Anna.
think.
Maybe just a quick comment around the agricultural pollution. I think it's really important to also understand that all the impacts in the river system are aggregated at the catchment scale. So if individual farmers implement the regulation, if not everyone at the catchment scale implements regulation, or the regulation is not designed to control the pollution at the catchment scale, then we'll always have a problem with the water quality, because the water quality in the river is a result of many things happening around the catchment or upstream or so on. So I think this connectivity and the regional view of the water system is really important. I think both what Simon and I are talking about are not small changes. So they're changes in the way how the systems, regional or national water systems, are designed from the kind of water and pollution balance perspective, which then enables individual abstractions, discharges, farms, and so on to come to their almost limit of abstractions or discharges to maintain the system. So it's a bit different, I think, way of thinking about the water cycle and water management, in a sense that you're trying to control the large-scale water balance and then give boundary conditions for the in-catchment water management activities, if that makes sense.
So, Simon, do you want to pick the next question or comments from?
What I was wanting to do is just to follow this line a bit more, and thinking about
Sure.
one of the earlier questions about monsoon, and also Anna's points about engineering the climate. As I mentioned, I've worked nearly half my career in China, and I've been involved in sort of major basin-wide solutions, especially in the Yellow River, and also the regions around Beijing, where they were undergoing desertification. The Yellow River used to not reach the sea for 100 days of the year, but through massive reform of the way that they manage their water system and abstraction, and by planting of hundreds of thousands of square kilometers of forest and greenery, and terracing hills, and changing the way that they manage their land, they reversed that. The river flows all year long, and also around Beijing, which was undergoing desertification, the average rainfall has increased very significantly over the last 2 decades, and that process has reversed. So these things can be done with a basin-wide approach and a strategic vision to what you're doing. They did also implement much more of a reversing and trying to desalinate and send the water back up. That didn't work. The economics 10 years ago weren't right, and the time wasn't there for it yet. So maybe that's a sort of a future solution.
So let's take another readme then. So we've got taking supply downstream in upland catchments lends itself to pumped storage schemes. In these situations, there must be combined benefits of the potential for hydro generation and the potential to balance the grid during times of excess renewable generation via additional pumping. So to me, this is the big thing. I think reverse water cycles, the concept kind of depends, or it's the opposite of what we were doing. We were taking from upstream because that saves us energy, particularly in upland areas where we've got the gravitational forces working in our favor, and frequently we would have the abstraction point up sufficiently high that almost all of the pumping through the treatment works could be done under gravity. We're kind of losing all this benefit and having to pump back upstream. So I like this idea that maybe, well, could hydro then give us some of that energy back now that we've got bigger flows in the river? Or is hydro just a environmental nightmare?
I think that the sort of run-of-the-river type of hydro, where you're just getting those sort of smaller drops, is pretty marginal. The amount of energy that you get from it is not that great. It's an unfortunate reality of hydro that it works when you've got a really big head of like 100 meters or something. Then it's wonderful. But if those heads aren't big, it's just not it's not worth it. The infrastructure just doesn't yield enough energy. However, this system requires lots of pumping. You know, this idea of the reverse cycle, that circular, I mean, any kind of circular water, circular waste, any circular economy solution needs energy, because you're going back, you're going against entropy. The tendency is for everything to mix up and become random. If you want to sort it out, you've got to put energy in. But you do have discretion about when you use that energy. And of course, we are moving towards energy systems which don't produce the energy when we want it. They produce it when it's available. So the coupling of the energy intensive aspects of the water system, together with the variability of renewable sources, can be very important. And whilst I don't think when you're using it for supplying the water that you're going to have it as a pump storage system, the fact that you store the water, you pump back up and you store it for a while before you use it, is a form of energy storage, not because of its gravitational potential energy, but just because you're using energy when it's available to put it there, and then maybe you don't use that energy and you supply from your reservoir when you're not. So you're balancing the energy system. So these things have to be very coupled.
Yeah. And to me, I mean, the ultimate and what might have to happen in some countries, if you're taking the extreme of this, is it has to be desalination, because there are plenty of countries that I've worked in which you don't have a lot of rivers going out to the sea. In fact, they're mainly using desalination at the moment, but that would kind of be the ultimate if we had absolute energy to spare. But I don't think that's what you're proposing, really.
I mean, that is an extreme end member, and we are doing a lot of the engineering design for NEOM in Saudi Arabia, and we've also done a lot of work in Riyadh. These are places entirely supplied by desalination. Currently, a lot of that is fossil fuel based, so bad idea, but it's all they've got. For their future plans, they are transitioning towards entirely solar and wind powered desalination, and then basically a completely closed water loop where that desalinated water is reused as much as possible, and minimizing discharges, and also recovering all of the minerals and the biosolids and the other materials that move in it. So those systems are possible, but only applicable in very extreme environments such as Saudi Arabia. I mean, that's not going to be a UK type of solution at a large scale.
So why then do we have the likes of Beckton?
Beckton is supposedly there as a backup measure. It was only ever intended to be used at those times when there is a fairly severe drought and you cannot take further water from the River Thames. Yeah, it had the slightly unfortunate thing that a few years ago, when that very situation arose and they went to switch it on because they hadn't been using it regularly, chug, 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 boom, it didn't fire up when they needed it. So that does put some warning on the backup approach for that. But I think in all these things, diversity is an important part of the solution. You know, you want to have some of those backup measures. I'm currently working on the water supply plans for Hong Kong, and there it's adding quite a lot of desalination now, moving in that direction, because they just don't have the resources available locally to be able to meet their needs by any other means. So it depends on the situation. It depends on what you're covering. For the UK, desalination is not going to be the big story, but I think that this abstraction closer to the river, taking fresh or at best slightly brackish water, is much more efficient than full desalination, and could be more of that solution.
Yeah. So Anna, do you want to pick a question next, or a statement, comment, suggestion?
Well, I mean, I think the questions are, I think discussion went, in one direction. I will, however, try to kind of just bring it back to I think, because I think the second question in the kind of second one that was voted in the initial poll was around, I think there were two that were kind of equally weighted. So one was around what is most significant challenge in developing and testing something that might look like water cycle atmosphere interactions, and if we could do it, what would what would be next step, how we can take it into implementation. And I would really like maybe to hear some questions and comments around maybe kind of first initial understanding what people understood as what actually needs to be done to reverse the feedback to the atmosphere. So I know it's, what I'm thinking of at this stage, but I think first comments and maybe the first one around what they envisage might be beneficial would be really interesting if there is anything around that in the audience. So I'm kind of posing question back to the audience to see if we can get some few or one or two different suggestions, or at least further questions if something is a bit unclear at this stage.
Yeah, so hands up everyone on that. In the meanwhile, I'll start myself. So am I right in thinking that you're proposing that for at least for certain areas, what we need is a lot more like ground cover, trees, etc. So we need to have a lot more area in which we're going to get infiltration, so rewilding, reforestation, etc. But then we also need greater areas of water so that we get evaporation, so that we then get local precipitation. Is that how we would implement it?
Yeah. So the honest answer is I don't know, and I think the what actually needs to be designed, I think, will be very context specific. I think the ultimate thinking is, what do we want to achieve, and what do we want to achieve requires to understand where we are at the moment. So I think for me, the first step would be to really quantify the interactions say for the UK, I'm thinking now about the UK context, to quantify interactions as they are. Because what we do have an evidence that in some regions, there is a very strong feedback. So India is one of the examples. But what happened in India is that they transformed lots of their barren land into the agricultural land. And of course, agricultural land, and they irrigate intensively. So that irrigation water and evaporated water created a really, really strong feedback in the monsoon. So they already are not only modeling, they are actually observing changes in the monsoon. And for them, because monsoon is just a couple of months a year, any changes in the onset or the kind of end of monsoon are really important from the water management perspective. So this is, some examples where we know there are strong feedbacks. What is happening in the UK, we haven't tested, but I think the question there, I think, would be the question of scale, and I think the other question would be, what is the climate at the moment? How are extremes at the moment? And what do we want? Do we want to dampen them? Do we want to make them? What do we want from the climate scenario? And then kind of testing different land use and water management options to possibly create that feedback. So I think it will be a combination of land use change decisions and combination also of the water management decisions, because we can also control the water cycle, and we are controlling it intensively by our obstructions and discharges. So I think that will be another, part that would need to be looked at the same time with the kind of just purely land use change.
Yeah, so we've had a brilliant question on that come in. Should we rewild agricultural land in the UK? Do you think that's going to help with your water cycle proposals?
Oh, for me, I would definitely test that. So I think there is a huge, maybe potential opportunity that we could have a scenario. What if we would, make UK an agricultural, country, try to be as self-sufficient with the food as we can be? Isn't it? The huge problem with the food is the imports and the trade and putting the pressures. Of course, more food, there will be more problems with the pollution and so on. But I think this would be really, really interesting scenario, in a sense, maximizing the agricultural production in the UK, and then thinking, first, is there a feedback to the atmosphere? Second, what we do, what resources, what we do with the pollution. So for me, and I think there are lots of benefits from the kind of self-sufficiency. So for me, that will be like a super interesting, at least modeling experiment in the first instance.
Yeah, and the self-sufficiency doesn't actually have to cause more pollution, take more land, etc. So work has been done to show that a footprint the size of Greater London could provide all of the protein requirements for the entire planet. So not just for the UK. But yeah, Simon's hands up too.
Yeah, I was just wanting to comment on this. I'm a great fan of rewilding and having as diverse and natural a system as we can. But a lot of that is for the sort of 30% of land that we're not currently farming. And I think more important in terms of the water cycle and also our food production is that 70 to 80% of the land that is farmed, that is currently under an industrial system. And that whilst we're not going to go back to a sort of Neolithic period wild system with big mammals running around and things, I think we need to think more about our role as human beings, as stewards of natural systems, that we need to learn a lot more about how we work with a diverse mix of other species to produce nutrition that we need, which might not be quite the same things we eat now, to produce that nutrition and to support ourselves where that main agricultural system isn't just producing food, it's producing a big variety of ecosystem services. So it's providing climate services, it's providing hydrological services, and it's, we live much more closely with it, and that communities are much more connected and involved with the land around them. Their lives are a bit more involved in that, because psychologically, that's what we're designed to do. So we're designed to be a part of a living system, but we have kind of lost a lot of that. And through our industrial processes, yeah, we've gained great knowledge. We can do quantum computing and AI and all sorts of things, but we've kind of forgotten how to really work with other species and other natural systems. And I think we need to learn how to do that, rather than the idea that we just rewild and send it back to some ancient idol.
Well, I think that's interesting. You mentioned not large mammals and stuff like that. I think part of the thing we need to do is to learn to coexist with the animals that we hunted to local extinction. At least we can't bring them back if they're totally extinct. But things like deer, the deer that we have here, basically in Scotland anyway, they consume. They wreak havoc on the natural environment. You don't get trees growing, etc. It turns the what seems to be a wild natural landscape in Scotland is not the way it used to be. If we had more apex predators out there, other than just, rich people with shotguns taking down the deer, then we would have more trees, etc., which would result in a much better wet landscape, I think. We've also, for Anna, I think, a question here, or read me, are sponge cities part of the possibility to control feedback?
So I'll give just a very short answer, because I think there was a hand up, and maybe it's nice to get comments
sorry,
from
did I
the
miss it?
audience. But I would just say yes and no. I think sponge cities are initially designed to actually capture basically excess water. And it helps with the flood mitigation. But do we want to just, capture all the water and discharge it somewhere? I think this is the whole discussion today, which we probably say no. So I would say sponge cities are part of the solution in a certain conditions, but definitely not the only one, I think.
And sorry, yeah, who had their hand up? Apologies, I missed
I
that.
think it was Jacob. Yeah.
Ah, yeah, Jacob.
Oh, hey there. Another thing that I think might be useful for like managing the water cycle is like having possibly more permeable surfaces. Like, for example, not sure if you ever heard of this scheme called the Grey to Green scheme for Sheffield, but it basically has like the principal aim of having a better urban design whilst bringing more greenery into the Sheffield area, and therefore having more vegetation, so like more permeable surfaces. So I was just wondering, I'm not sure if this is happening in many cities like Sheffield or in other places worldwide, but how significant do you think this could be for like the future if other countries do things like this in the future?
Simon, isn't there quite a lot of that going on in China? Have you got experience of that?
Yeah, I mean, what you're describing, Jacob, basically is what we're referring to as sponge cities. This is a concept of greening the city and allowing it to absorb more of the water. In the UK, we tend to call this sustainable urban drainage, SUDS. Actually, sponge cities is very much the Chinese term for this. And I was quite involved 10 years ago in the launch of it there. In China, the concept is a little bit wider because it has more of a water resources aspect. So the idea is to actually really try and absorb that water and be able to reuse it and recycle it within the urban setting. And it is a very great principle. But ultimately, it's cities, and cities actually cover 3 or 4% of our land. So it's always going to be a localized solution. It's not you're not going to change the major flow within the river basin by these measures, but you can make enormous differences locally. And those differences can be in terms of the local flood response and the quality of the water, because those more natural systems will extract some of the pollutants. But they can also be part of how we address the intermittent discharges. So when it rains and our sewers overflow and things, we can solve those by building big tanks, big concrete tanks, and storing everything in there. Or we can change our surfaces so that the water flows into the sewers much more slowly and we don't get as much of an overflow. Much more benefits, but much more difficult to do. So yeah, it's an important part of the solution, but it's not the only way forward. Anna.
Yeah, I think to me also, I'd encourage people to have a look. Jacob's shared a link to Greater Green in the chat there, and I think, to me, SUDS back in the day in the UK, we were talking about porous pavements and stuff like that. So it's just a different way of having your concrete. But yeah, the sponge cities with the green environment gives you a much nicer habitat as well. The opportunity for more rivers and stuff within cities. So that's brilliant. Michael, do you want to make your point as well?
Sorry, it sometimes takes me a while to figure out the headphone.
Yeah.
Yeah, in regards to the sponge cities, I know like in places like China, it's ideal because of different, I guess, geologies. But in the UK, especially up in the north, a lot of it's impacted by like glacial retreat and whatnot. So we found like when we obviously go out and do percolation tests, and part of my job in pretty much every development as part of the Serious SUDS guidelines and to meet MPPF requirements, as well as building regulations. But what we often find is mostly that they generally don't work. So like things like the soakaways wouldn't be feasible, which means then that the water then has to be filtered through other SUDS methods and then straight back into waterways. Like ideally, obviously, it would be fantastic for it to soak back into the ground like they proposed in the green cities in China, but obviously with it just ending back up in waterways from surface water runoff, it makes no real difference to, I guess, a green city, as it's just part of a drainage system and goes back into the same source it would in the first place, which obviously then we just need to make better designs, which we obviously try and account through hydraulic calculations and whatnot when we're creating designs, but it's all just a work in progress, and obviously climate change getting worse impacts it more and more.
Yeah, radical change is required. I've just seen the time, in fact, so I'm thinking we better move on into the next section. So I think we should consider some actual action now. So how do you want to get involved with, we're going to call all of this reverse water cycles, mainly because it would be unfair of me to now ask Ethne to change the poll. So yeah, can we launch the next poll on action? So yeah, what's next? You can please let us know if you don't think we should do reverse water cycles for whatever reason at all, and feel free to mention your reason in the poll. If you think other people should be doing it, if you think basically this is something for DEFRA, or this is I don't know, that there's someone that isn't me that should be doing it, please let us know there. If you actually want to get involved and do reverse water cycles or help with reverse water cycles, please mention that as your answer. And if you are going to be doing it, as in more than just I would like to do this, I'm actually actively going to be doing this, please vote there. I would like to think that Simon at least will be voting for that one, although Simon maybe can't vote.
I don't
like
have the ability to vote.
Yeah, neither do I. So we'll assume an extra one for Simon on there, and probably Anna too. In fact, yes, while people vote, I might as well find out how Anna, how would you vote on this if you were allowed to vote?
Well, I mean, I'm going to do the reverse water cycle, but in modeling. So
Yeah.
so I will be the last one.
Brilliant. Excellent. And Simon, I trust you'll be doing reverse
yes.
water cycles as well.
Oh, I'm doing it already.
Yeah. Cool. Excellent. So 50% have voted. In fact, maybe we just keep this. Oh, now, can people see the results as they come in?
Yes.
Mhm.
Can somebody who is able to vote and has voted, could you let me know whether you can now see what the result of the votes are? Because that would mean that we don't have to close this vote now and we can just quickly do the rest of the wrap up.
I don't think they can. It's
Wow.
just come through on the chat.
Oh, okay. Oh, so sorry. Yes, no, we can't see the results. Right. Well, I'm going to read out the results as they stand, but we'll keep it open because we had greater percentage responding earlier. So top of the list, we've got I want to help to do reverse water cycles with 65%. And then it's a joint tie for everything else. So we've got a couple of people who don't think it's a good idea. It'd be great to hear your thoughts in the comments on that. A couple who think that others should be doing it. A couple who are going to be doing it themselves. Particularly those who don't, in fact, for all of you, you can turn up and let me see. No, I'll come to this in my slides, but for now, while we get the last few votes in, let me just say that if there's an idea for radical change that you'd like to discuss with others, perhaps something that we discussed today has triggered something, or maybe you have something completely different that you think we should be doing, some radical change that could help with water climate issues, please head to waterclimatediscussion.com for instructions on how to post your video to LinkedIn so that we can all share and add comments. I think Ethne can hopefully share the link. So it's wcd.andai.com/WCD. I hope you've got that one in there somewhere. Basically, for those next steps, what you want to do is just grab your phone and then record your idea in a video on your phone and post it to LinkedIn with hashtag radical change and @ water space climate space discussion so that we can then see it and then we can post it to the group and everyone can comment on it. If you don't want to do a video, that's absolutely fine. You can just write what your suggestion is, type in your suggestion for radical change. And yeah, post it to LinkedIn, hashtag radical change and @ water climate discussion. So yeah, the poll has not changed that much since I last mentioned it. So you feel free to vote still. But thank you everyone very much for joining us, particularly for Anna and Simon for all the preparation they put into this. And for Ethne as well, really for making this all happen. Thank you so much. But thank you everyone for joining and putting your mind to this task. It's massively appreciated. And if you'd like to work out how we can implement reverse water cycles, for all of those of you on the I want to help do reverse water cycles, please turn up next week, same time, different address, where Anna and Simon are going to be leading a very practical breakout workshop on this at the same time next week. Also, please, for those of you who don't think we should do reverse water cycles, if you could turn up there, this is going to be a pre-mortem. So we're basically going to be looking back from 2044, imagining that things haven't gone particularly well in terms of climate change and thinking, what could we have done? What should we have done? Those of you who don't think water reverse cycles are a good idea, the barriers to those are going to be a key part of that brainstorming. Or you can join Amanda, Laura, and myself. As I mentioned earlier, we're going to be trying to work out how to fix water aspects of food so that we can reduce water pollution and irrigation demands and so on. Then Daniela and Mark will be exploring sponge cities further. It's all interlinked really with the water cycle. So yeah, there's more on sponge cities there. Steve's going to be doing household water management measures. Tom will be hosting discussion on how we make all polluters pay. And Pierce would like your help in getting to the bottom of waterless sewerage. So yeah, we're going to be running these pre-mortem brainstorms together, so it's going to be even more interactive than today. Again, with this one, you can just type your ideas on post-it notes. So if you don't particularly like speaking out, that's fine. But if you want to, you can. But yeah, we're really looking forward to seeing you again then, or at least reading your comments on those post-its. So yeah, thank you very much. I'm wondering, Ethne, do you want me to hand back to you now, or do you want us to do a tiny bit more discussion first?
I only need a minute or so, so happy for you to carry on.
Okay, right. Anna, final thoughts then. What are there other elements that we haven't addressed yet that we should be?
No, I think this is great. I think for something that we call, and I think it is a radical idea. I really think we had a really good discussion, which and for me, I think the most exciting thing is that there are people who want to work on that or either are already doing that. So I would really encourage those people to get in touch, and I think also those that think this is a stupid idea. I think challenging radical ideas at this stage really needs to be challenged. So I think ideas on one side and challenges on the other side would be really helpful at this stage. So I think, Martin, what you mentioned next week, if people can join, we can continue discussion and so on. I think that would be absolutely amazing. I really enjoyed the event. So thank you all.
Yeah, brilliant. Simon, last 30 seconds.
Yeah, I think the main thing is to take a positive attitude. I think what we're presenting here is that as people, we can work with a natural system. We can engineer things, we can plan things, we can make a difference, but we have to learn a different way of thinking, so that what we create adds to being part of our whole planet, rather than taking advantage, taking the easy route, consuming and destroying. But it is possible. You know, our current path might be heading us towards the disaster that our pre-mortem is going to be discussing. How did we get here to this terrible state? But I do believe it is possible for us to all live very well on this planet, all 10 billion or so that there will be. But it needs careful planning and change and effort. Thank you.
Absolutely. Yeah, thank you very much. Okay, we'll hand over to you, Ethne, now to close. Thank you very much, everyone. And Ethne, is there a way that we can save the chat here so that that can be further addressed next week as well, particularly any elements that we missed?
Yep, that should all be saved, so I can send that over to you afterwards. Just to echo
Wonderful.
you, Martin, thank you so much to Anna and Simon for their presentations today, and of course to you as well, Martin, for your expert chairing. And of course to all our attendees who make this kind of worthwhile, and thank you so much for putting all of your thoughts in the chat and for getting involved in the discussion. I have put a link to the FWR newsletter in the chat as well, so please do register for that. It's just a free newsletter which tells you what's going on with the FWR and links to analysis as well. And I would really encourage you to get involved in the pre-mortem discussion. Just to let you know that the next FWR event will be taking place on the 4th of December, and this will be focused on future home life with water in new build residential developments. And you can register for this on the FWR and IES websites. Again, a massive thank you to everyone involved. Have a great rest of your day. Thank you.
Brilliant. Thanks.